will start the career day. And I see Miss Sharon already here. Yeah. Good morning, Miss.
Yeah, good morning.
Okay.
Good morning.
So before we start, I'm gonna. Yesterday, actually, already being explained briefly about the all edu space, but I'm gonna repeat it just a brief description. Yeah. Before we start, okay, All in Edu Space is an independent university consultant that offer mentoring learning programs for students who want to pursue their studies at their dream university. Yeah. Uh, they have professional team commits to prepare students to enter the dream universities abroad and reach their future goals with the tailored guidance for qualified and approachable mentors. Okay, so that's a brief description of All in Edu Space. And today we will have another workshop related to engineering, Miss.
Yeah.
Yeah.
Correct.
So today, Miss Sharon will do the workshop for engineering. Please pay attention, yeah, and get involved. Okay, time is yours, Miss.
Okay, so yeah, thank you very much, Mr. Julius, and good morning to everyone. So excited to be here. I think this is one of the first times I think talking to you guys here. I saw around 30 students, yeah, today. And wow, I'm really excited because I can see all of you. I mean, like through the camera, it's very nice. So yeah, I think today we're gonna be talking a bit about engineering, and I want you guys to participate. And if you happen to have any question in the middle of my presentation, or if you have any suggestion, or you can answer even some of my questions, please feel free to interact. Yeah, probably I'll just start sharing my screen just to start this workshop. And I think I would also like to introduce our company just briefly. I think you guys have heard from us yesterday. I'm pretty sure you have been involved in our previous workshops in business and also in design. Hope you guys have a great time. And yeah, because in All In, we are committed to help grade 7 to 12 students to get into their dream universities. I think I'll just go again very briefly about this. We have our flagship program, which is the admission mentoring program, which helps students to get into their dream universities, their best fitted universities. And in that case, we also help students to understand what career opportunities they have in the future, getting to explore what options are there through programs, through workshops like this. Yeah, and of course, we still pay attention to your grades as well, because I think even in like advancing in your grades, it's also a form of exploration in itself. Yeah. And again, we have these 4 aspects of top university preparation: the academic performance, the exploration, which we will be focusing on today, the personal brand. I think this will be a good thing to discuss after this session, because you already know like 3 different parts, which is business, design, and engineering, and you can combine them to get into your personal brand. And also all of that will come into your writing skills when you start your application. Okay, oh, I saw like, wow, there's gonna be points. Okay, seems fun. All right, so I think before we really start on this or on today's topic, I would like to get a reaction from the students here who is interested in engineering. So I will be talking about process engineering today, just a bit of process engineering, one aspect of it, which is very small aspect of it, which is the quality control. So I wonder here who have heard about process engineering before? Can you give me a thumbs up? Let me see on the participants. I see no thumbs up yet. So is it like very new for you? Process engineering, or maybe quality control then? Who have heard of quality control before? Okay, I see some. All right, I see some thumbs raised. Okay, great. All right, so not sure about the others. Maybe you have heard like other, like other terms about it, but maybe you have like about quality assurance. What else? Like maybe you saw terms like ISO or like GMP or other stuff like that. We will not focus on that today, but we will look at it more on the engineering part. Yeah, because actually behind process engineering and quality control, it's a very simple statistics that we can use. And today we will look at how do we control quality using a statistical process control chart or SPC chart, which is actually, again, it's involving very simple statistics that I'm pretty sure most of you here have already tried to calculate before. Yeah, and we will take a look at the case study. In this case, it's a tissue paper production, very mundane looking stuff that we use every day, but let's see how we can calculate that. And I will invite you guys to calculate as well. Yeah. All right, so actually process engineering. So when you hear about like process engineering, yeah, it's actually a pretty broad field, yeah, because you can see this not only in one type of industry. It can go across or abroad at different industries. It can be pharmaceutical companies, it can be food engineering, food companies, right? But the field itself focuses on transforming raw materials into the end products with maximized results and minimized cost. Yeah, so a bit similar to general engineering definition in general. Yeah, but then we look at this maximized results as our focus. Let me get my laser pointer so you can see it more clearly. Yeah, so when we're talking about maximized results, what do we actually mean by maximized results? Okay, so in this case, of course, we want to create some products that have the best quality, right? And we want to achieve that through what we call as quality control. Yeah, okay, so this is like quite hefty, like I think the first two slides already give you like tons of definition. I will not ask this as a quiz. I think for the teachers here, please don't ask the students this definition as a quiz. I think this is not really word by word definition is not my focus today. But what I want to share is quality control is a very important process, although many people overlook them. Yeah, but it's very important to ensure that the whole process actually works smoothly. Yeah, all the attributes of the product is suitable for its intended purposes. Yeah, and it also satisfy the customer's expectations. So that I don't speak about like very hefty definitions, I would like you guys to look at these three pictures over here. Yeah, so this is what happens when you fail to do quality control. Okay, so yes, manufacturer. Okay, thank you, Leon. And yep, maybe I'll invite you guys once again, like when you see all these examples, like what do you think went wrong? You can pick either one of them. You can start from whichever. You can mention like both of three of them, like what happens. Yeah, what happens in their production process? What do they overlook? Or what's going wrong in this case? Just take a wild guess. Anyone, probably? Okay, very, very straightforward. Yeah, misspelled Dunkin' Donuts. Okay, burnt phone. Good, yes. So what do you think happened in the burnt phone? Like what can go wrong that causes the phone to burn? Rosemary, I think you're talking about the center, yeah, the middle picture. Yeah, it's half empty. There's a half empty bag of like, what's that, like chips over there. So okay, overcharge is one reason. Yeah, so good. I think you guys already quite grasp what happens over here. But let's see how an engineer might be thinking when they see all these examples. Yeah. Yeah. So you might want to think like what criteria that you can give, yeah, or that you can use to say that this product is in good quality. Yeah. So this is like the opposite of my question just now. Like what I asked just now is what's going wrong. But if you want to determine, or like this product is in good quality, so this product have to have what kind of attributes? Can you also guess in this sentence? If you are about to finish the sentence, like the product has to blah blah blah, what will you say about like these three products? So for example, if I say this phone is in a good quality, yeah, so this phone has to be able to do something, or like to have blah blah blah. Too broad probably. All right, so just to save time, yeah, you can basically like define the quality through, like looking at these pictures. Yeah, you can say like, oh, the first one, the product, or like the sign basically have a correct order of the letters. Yeah, that way you can say, oh, this signboard is printed correctly, or this signboard is in a good quality. It serves its intended purpose. Remember the first definition that I gave you. If the quality is good, like it's achieved through quality control, then it serves its intended purpose. Yeah, you don't want people to go into a misspelled Dunkin' Donuts drive-through counter. And the same goes for the chips over here. You have the same amount of tortilla chips in a bag, and yeah, maybe a bit complicated for the phones. Yeah, for a good quality cell phone, they have to have this system that keep the phone cools, otherwise it will burn down, just like in the example. But what process to decide it reaches minimum standards? Okay, yeah, so that's a good question to ask when you're actually manufacturing a product, right? We will look at it actually, what are the minimum standards, or like you can actually set that and then quantify that in order to get a measure, in order to be able to measure the quality of a product. Okay, yeah, but actually there's one step in like looking at this problem as an engineer, which is to ensure the quality. It is easier to make the quality a quantifiable attribute. Okay, again, this is might be big words for you guys, but basically you want to set a number, right? You want to set a number, because in this case, in these sentences, like, what does it mean by having the same amount? Like, do we have to like, how can we say the first bag and the second bag have the same amount? Or how about the system here? Like what is cool? Like what temperature is cool? We don't know, and we cannot like maintain that very easily, right? So what we have to do is we put a quantifiable attribute, or we put numbers in a certain quality in that product in order to make it easier for us to monitor, right? So for example, in this case, for the order of the letters, there is no tolerance. Yeah, so this is probably a bit, strict in this matter, that they have no tolerance for any mistake. Yes, so you have to really spell the letters correctly. Yeah, it's probably a bit different with the center, with the middle example, because when you say the product has to have the same pieces or weight of tortillas on your bag, you probably will not get like exactly the same pieces in order to get the same weight. Yeah, but there's where this process as a process engineer, I'm sorry, you have to make sure that at least they have not that much variation between the bags. Right. Correct. Yeah. So the last part is you have to set the maximum temperature that your system will need to maintain. Yeah. So when you go into like a light, imagine a long manufacturing process of that cell phone, you might want to like use that cell phone to a certain extent or heat that to a certain extent, and then you measure the temperature of it, and you see like, oh, once it gets to maximum temperature, do they increase? Do they keep increasing, or whether the system works to keep it low or at least keep it at the same temperature? Yeah. So that's kind of like the, how process control engineer look at their quality control process over a manufacturing line. All right. So yeah, the question is, how do we actually control the quality of a product? Yeah. Again, maybe you think this is quite far. Maybe you think this is like, oh, I'm not working in the manufacturing line right now. But later on, we will see like how you can actually use this in your daily life. Yeah. But first, let's take a look at the example. Yeah. Actually, there's a quite simple step like monitoring, recording, and analyzing. Yeah. And this is composed in what we call as the statistical process control, or SPC chart. Yeah, again, this chart is widely used in different types of manufacturing. Later on, probably if you have time, I can show you just a bit of the video where we can use this, or like as a day in the engineer, like what kind of graphs they're actually looking at and how they monitor the process. Yeah, but for now, through this SPC chart, which we will try to make one today, you will be able to monitor the quality of this product that you want to measure. Yeah, again, I'm actually putting not a perfect chart over here, if you notice. Yeah, later on we will see like what's wrong with this chart. But basically, the first one, you want to monitor the quality that you want to measure. The second is you want to record and organize the data in the spreadsheet before you're plotting this into the graph. And once you're plotting this into the graph, you want to use basic statistics to analyze, because without a proper analysis, this chart means nothing. Yeah, it's just a record of, observation of whatever quality attributes that you're looking. Maybe it's weight, maybe it's temperature, whatever. It doesn't have a meaning without your analysis. Yeah, so when we zoom in, so once we get into this SPC and then we zoom in just a part of it, yeah, I want to introduce to you like some of the components. Yeah, maybe here I already point out on the y-axis and the x-axis, there are different variables. Again, maybe just to know how familiar are you with graphs. Anyone can say like which we always have like two variables, right? Independent and dependent variables. The one that you can control and the one that you get as a result. So which one should be in the x-axis? Which one should be in the y-axis? Maybe this is a bonus question if anyone can answer this. For the dependent and independent variable, which one should I put in my y-axis? Which one should I put in my x-axis?
For the x-axis, that is the independent variable, and for the y-axis, that is the responding variable.
Okay. Yeah. Thank you so much. I actually cannot see like who's actually talking just now, but thank you for the answer. That's great. Yes, exactly. Like we're gonna put our independent variable on the x-axis, which is in this case is the sample. Yeah, so this is the amount of the sample that we are measuring. So imagine like there are 15 phones, or there are 15 bags of tortilla chips that we will be measuring. And in the y-axis is the quality characteristic, which in this case, if you're talking about the tortilla chips, then the quality characteristics might be the weight, right? So for number 3, you see that maybe it's like slightly below 10 grams this is not the real graph. Yeah, so this is just a example, just an example, but that's how you look at it. Yeah, this is just a recorded or the measured data that you will plot on the graph. And the horizontal line over here is the average, yeah, which is the central, not really the central, I mean like the quote unquote central amount of the from the measured data. Yeah, you will plot it as the horizontal line just to see, you know, the middle part of the measured data. Yeah, not to be confused with the median, of course. Okay, so and then what makes it different from this control chart, yeah, or the SPC chart, is that we also have this dashed red line over here and here, which is the lower and upper control limit. Yeah, and how can we calculate this is that we put the 3 times standard deviation of the measured data and then plot it into horizontal line. Okay, so maybe for some of you, again, like you maybe think like, what in the world, like, is this standard deviation? Maybe this is also another new term for you. You probably might heard of it somewhere, but you don't really know what it is. Yeah, but just a note about like standard deviation, because it's very important in this case. So again, when you're imagining that production of your tortilla chips, every time you buy a tortilla chips, bags in a supermarket, if you buy 10 of them and then you want to, like, you know, pour out all the contents and weigh for yourself, like you have a scale and then you want to weigh it for yourself, you will find that it's not exactly the same, like between the bags, but at least they will have like slight differences, right? So those are the range, right? Those are the differences that you find from all of these samples. Yeah. So the measure of how spread out your data compared to the average. Yeah. So not only the differences, but when you compare it back to the average is what is called the standard deviation. Or in this case, there's a symbol over here, sigma. Yeah. And this is how you see, like, if the standard deviation gets bigger, or it's if the number of the standard deviation is larger, that means the whole samples that you have are more spread out in terms of their numbers and their values. Yeah. And if you see here, why is it like 3 times standard deviation? Yeah, this is already a consensus. So why 3 sigma? So based on this bell curve, maybe this is a bit advanced. I will not talk extensively about this, but then basically if you are setting 3 sigma or a 3 standard deviation, you will have less than 3% chance. Yeah, maybe you look at this part of the bell curve. Yeah, you will have like only 2.2% of chance that your measured data is you know, like slightly, it's like way off from your average or from your target measure. Yeah, so those imagine this as the fences, you know, as the guard, like you just want to avoid your measured data to exceed this level or this level. Yeah, so in this case, you know what's the maximum level, what's the maximum limit, what's the minimum limit. Okay, I hope I'm not going too fast. So I will just move on to our case study. Yeah, because I will share to you guys a spreadsheet. But before that, let me give you a context first. So imagine that you are making your own manufacturing line of tissue papers. Maybe in the case of course, we hope Corona will not be more severe. But if you remember back then in 2020, there's once a period where tissue papers is like not available everywhere. And then you probably want to start your own and you want to make sure the production is efficient. Yeah, so you gather up some data on wet strength. Yeah, so this is what they actually measure in like tissue manufacturing line. You want to know the strength of the tissue when it is wet. Yeah, so it's known as the wet strength. So your question is your production line efficient? Yeah, meaning, can you produce the tissue papers with the desirable wet strength? Yeah, so it's not too difficult to break when it's wet, and it's also not too brittle when it's wet as well. Yeah, so this is the question that you want to answer. No matter how you come up with the graph, you want to answer this question at the end, because that's what engineers do. They answer questions, they answer problems, right? So this is what you will do, right, in constructing your SPC chart. I think after this, I think right now, Ms. Teresia, you can share as well like the spreadsheet link, just to give you time to access and take a look at the spreadsheet. Yeah, basically I will briefly say about how to construct the SPC chart, just like that. Yeah, the first one, you want to organize your data, which I already give in the spreadsheet later on. And then you want to construct your graph, determine the X and Y variables, again, plug the data into the graph, calculate the average and plot it as the horizontal line. And then you calculate the standard deviation, and then you multiply it with 3, right? Both for the upper and lower control limit, and plot it as the new horizontal line. And then later on you check and you analyze what happened with your data. Yeah, so again, like this is the spreadsheet that I think Ms. Teresia already shared in the chat box. I will be shifting into the spreadsheet in a minute, but before that, let's get into, like the demo. I mean, like the whole picture, or step by step how we construct this SPC chart. Yeah, so you will have this data, the exact same data in your spreadsheet. Yeah, it's already been plotted there for you. Yeah, and okay, so in this case, again, this is very simple question, rhetorical question. Do you think the samples are within standard? We cannot really say, because we don't finish the complete SPC chart, right? We cannot analyze anything just from this plotted graph. And the first one is calculating the average, yeah, or the sum, or the central value of the data using this formula, sum of the data value divided by the number of data. But because we are using Excel today, we can just put in the formula. Yeah, so I think we will just use like just two very simple formula today to be able to get our average and also our standard deviation. Yeah. Okay, so again, I will shift into the Excel in a minute, but let me just finish this part first. Yeah, so you hope to get this line by the end of the first step, which is calculating the average. And the second one, you want to get your control limits, yeah, your upper and lower control limits through this formula. Again, if you do it manually, might be quite bothersome, yeah. But then you want to use your Excel, you want to make use of it, and then just use this formula to get your standard deviation. Okay, and then you hope to get this kind of final chart. Okay, so I will be looking at another, let me stop share for a while so that I can shift into the same worksheet that I have given you. Okay, so when you see this worksheet, you might see that there are 3 worksheets that are actually the same thing. Yeah, so I think we have around how many, like 30, 35-ish students today. The first thing that I want to do, you guys to do, is basically just copy that spreadsheet. Just copy that spreadsheet, or like duplicate that spreadsheet, so that you can have your own worksheet. Yeah, actually, so just like click, right click, and then duplicate, make another one, because I think you're free to edit. So you will have your own worksheet, and then you might want to rename it, yeah, so that you know like which worksheet is actually yours. Okay, you have there are 41 students over here. Okay, I think we still have time, yeah, to really get into this. So I think I'll just give you guys around 3 minutes to copy the worksheets. Yeah, because we will like go through this one by one. Maybe just spare the first worksheet for me so that I can show everything to you. Um, maybe you guys can copy this and then start renaming yourself. Yeah, I think there are 3 lucky students that have their own worksheet by now. So you don't need to copy, but for the rest, please just duplicate the sheet. Okay, I see people renaming stuff. Good. I just rename this one, yeah. Karen. Exercise. Okay, so I see Cluo was very unique name. Yeah, so for the others, like maybe let's have like around 2 minutes just for you to duplicate. Okay. I see Mr. Julius like already taking one spreadsheet for himself, and I'm waiting for the other students to do so. Yeah, before we like go through all these processes one by one. Again, I think you might have guessed like how can we do this, but just you know, as an exercise, if you don't really do it, maybe you don't really get the feel of it. So yep, maybe just 1 more minute to wait for you guys to duplicate again. Though it's very simple, yeah. Just click, just right click on the spread on the tab, duplicate, and then you want to maybe rename this. All right. This is maybe just, I don't know, maybe give to anyone. All right, I see a lot of students doing so. Don't forget to rename so I can like see who's doing what, and you also don't get your tab mixed up by other people. Okay, so let's start. I think we've coming to this step. Yeah. So remember what's the step, right? First, we already have our samples. We take like around 15 samples today, and this is also the same data set that I've shown to you in the presentation. Okay, so okay. Hi, Kenzie. If I saw that you're raising your hand, if you have any question.
Miss Sharon, is it okay if we make a copy of it ourselves? So like not in the bottom part, but make a different copy of this.
Oh, you mean to copy the whole file?
Yeah.
Yeah. You can do so. But then I mean, like we cannot see then. I mean, like that you're be working. You're working in it like by your own. But that's okay. That's fine too. Anyone else have any trouble with like getting their own worksheet? Okay, if not, then I'll just okay. Okay, again, if you want to copy this, or even if you want to like download this, maybe I will not really recommend that today because I'm afraid there's gonna be like different formats from like Microsoft Excel and also the Google Sheets. But I mean, like in theory, you can do this also in your, you know, Excel software on your computer. But yeah, let's do this just so I can share today's work with you. And again, the first step that we want to do is calculating the mean because we want to plot that into a straight line, right? So I already highlighted this yellow parts, which means that those are the things that you want to fill in with formula. And again, looking at the previous slides, you just put in your formula. Again, if I'm going too fast, or if you're not in the stage where I'm at right now, please freely raise your hand or put or like say in the chat box so I can pause. Yeah, but for the others who have been waiting, let's just get into this. Yeah, so you want to type in your formula, right? Average. Yeah, and then open the brackets. Yeah, so this is like another cheat sheet actually from the Google spreadsheet. Like they can detect what you want to calculate, but basically you want to have the average of these data sets over here. And then just agree with it, and then let's press tab just to accept this. Sorry, I'm still here. Okay, so right now you have only one value of the mean, right? So the next instruction is actually copying from above, right? Because you want to like have the same values on this part. Yeah, so, okay, I will start doing what I instructed here, and I will copy from above. So what I will do is I just copy, right? So do you guys think this is a correct step to do it or not? Yeah, along the way to do this worksheet, I will ask you if my steps are wrong, if my steps are correct, because that's what also engineers do. They try and then they iterate, they see, oh, whether I do it correctly or not. Do I make a mistake, or is it looking as what I intended it to be? Can anyone guess if this is the correct step or not? Or is there any error in my... Okay, so there's an answer saying that it's correct. Maybe, just maybe. Let's see. Okay, someone is talking. Okay, William said no. Right, okay, there is an error. Great, so yeah, let's take a look, because if you compare with the previous chart, it might be looking a bit small. Yeah, so what I will do is actually, zooming in here so that I can see a bit more clearly. So in my vertical axis, I will, maybe start from, not from zero, just for this case, I want to see, yeah, whether it is correct or not. Okay, so I already put the minimum score as like 400 as the minimum. And yeah, I think this is looking weird, right? Because your mean is like not a straight line. So what you want to do, right, is because you want to check, because, oh, actually your data is moving, right? So let's do the old trick that Excel have. Anyone can guess? Yeah, so you want to lock the data, right? Because no matter how you want to copy them, the data itself doesn't move, right? So what you want to do is you lock your formula so that it's stays still. I mean, like the average, the data set that they select stays still. Yep, you can try by using F4. I think mine is not working in Google Sheets. It only works in Excel. But if it does for you guys, please feel free to do so. But just the principle of it is that when you put a $sign, it means you want to lock either the row or the column. And in this case, we want to lock both the row and also the column. Yeah, so this is what we're going to perform. And voila. And we copy that across, all the data set. We should have the same amount of average, and you get a straight line, perfect straight line. Okay, is everyone following? Okay, so I think with the time limit, I'll just move forward to the standard deviation, which we will not need to plot into a straight line, yeah, because it's only there to help us calculate our upper and lower control limit. So again, standard deviation, you want to take the standard deviation S because we are taking the sample. Yep, and again, using the same, okay, using the same data set, you want to highlight, oh, sorry, sometimes error does. You want to highlight the same data set. Yep, you get your standard deviation over here, 26.56. So usually, like the average, the normal variation from the average line is around 26.56. And now we will use that to calculate the standard deviation, the UCL, or like the X plus 3 standard deviation, right? So what you will do is, again, use this, just type all the operators, right? And 3 times this one, okay? So you see there's a dot over here showing your upper control limit. Again, same instruction, copy from above. Oops, not working, right? So I think let's do the same old trick. Can you guess which one we should lock? Which from this formula is not moving? Either is it C5 or G5 that we should lock, or both? The standard deviation. Thank you, William. Yes, so let's put a lock on here. Yeah, we don't actually need to like put a lock on the C5 because practically all the mean is actually the same. Yeah, so no matter like where you are, it's actually showing the same value. And so you get this line. Yeah, let's do the same quick thing with the lower control limit. Again, it's the same formula, but it's using the minus instead of plus. And 3 times this one. And you wanna remember to also lock it so that you don't get error numbers. Okay. And then when you straight, if you copy that, you get, now you will have, now you finish actually your simple SPC chart. Yeah, so before I ask everyone the answer of my question, anyone finish and like get the same result as mine? If you wanna like give me another reaction so I can see. If you see that your graph is exactly the same as mine. I'm not sure I want to expose everyone's like sheet over here, but anyone have any trouble? Yeah, I think because of the time, we can move on. Okay, great. Some people are done and having the same result. That's great. That's great. So yeah, actually, so I think you're probably wondering like, wow, this is like too simple. Probably like it's just, you know, calculating 3 times and then you copy and then you make sure you lock where you should lock and then it's done. But yeah, I mean, that's the thing, right? That's the point, that you can actually use very simple formulas to, you know, think or like to create like tools, engineering tools that are very versatile. Yeah, you can actually use this in any kind of processes. Yeah, and so do you think this is, so do you think if you have this kind of control chart, then your production is efficient? That's our ultimate question, right? Yes or no? Just a simple yes or no question. Is it, do we need to troubleshoot anything, or is it already under control? Maybe a bit hesitant, yeah, but actually when you just see that there's actually no difference. I mean, like no data exceeding the upper and the lower control limit. So we can say that it's pretty safe. Yeah. Oh, okay. Kayla, how can I help you?
To copy like this number,
Where you are actually right now.
in the mean.
Mean?
Yes.
How do copy?
Yes. Not copy. I mean like to make the number like this that you showed.
Oh, you mean this one? Okay,
Yes.
okay. So basically, like what, first of all, you want to type the formula, right? It's average. And then let's just ignore this. You cannot ignore this suggestion. But basically, like you want to click on the wet strength, because this is the data that we get, right? This is our known data. So you just click on this first, and then you drag until the 15th. Yeah, so you hold your mouse and then drag it down, and then you want to close it with a bracket. But it's not enough, because we know we don't want to change our data set over the different columns, different rows, sorry. So you want to put manually, either you can press F4, yeah, to give a $sign, but you actually can also type that manually. So just give a $sign in front of every alphabet and number, because we want to lock the row and also we want to lock the column. Are you following?
Yeah.
Yeah. Is it looking right like this right now?
Yeah. It
Okay.
is.
So when you enter, you should be getting this 496.33. And once you are at it, you see that's a small square over here, right? And then click on it and drag it down until box number 15, and you will get the same result.
Okay.
Okay. All good?
Yeah.
Okay. Yeah, you probably want to try it again later. Yeah. So I think because of time, thank you so much, Kayla, to speak up, and probably you can like meddle with it later on at home. You are free to do this. I mean, even outside the workshop. But then let me just finish this with some examples. Yeah. I hope I'm still sharing the screen. Yeah. Again, today my point from today's workshop is actually not, for you to create like a perfect control chart. This is just to ask you to think like an engineer, right? So why people create this kind of tool? Yeah. So maybe you're doing your own small business. Maybe you're making cookies. Maybe you're making, I don't know, maybe you're selling phone cases or anything. Yeah. And probably you want to know whether you are actually, maybe you're doing certain campaigns and you want to know whether your campaign is successful or not. Yeah. Or maybe you want to know whether if you're making cookies, are you making quite the same amount of cookies? Are they on the same or like uniform shape and weight and stuff like that? You want to probably monitor that using such control charts. Yeah. Or maybe later on, if you're already driving and then you feel like my car mileage it's a bit boros, like you use like too much gasoline per car mileage, and you probably want to know like what's the cost, yeah, and like what's happening with my usage. Yeah, so you probably can monitor like what's your car mileage using that control chart to know the efficiency of your gasoline usage. Or maybe if you happen to be an assistant coach of your sports team, maybe basketball or soccer teams, and you are having this task of like, okay, I want to help my coach assigning like the all-star team for a competition. You want to see like who are, among all the teams who have the consistent players or like consistent number of shooting, a number of points per time of shooting, stuff like that. You can always use similar tools actually to know whether your teammates are a consistent players or not. Yeah. And later on, this type of control chart is actually also, you can use that for something else, for like another career, for example, chemical engineers. You want to monitor the filtration time and contaminant when you're purifying water, or as a food manufacturer, you want to, measure the cooking time and temperature of meat products like sausages or corned beef, stuff like that. Or even software engineers, you can use that chart to monitor the code errors per update release. Yeah, because for a software, it needs to be regularly updated, and you want to see whether there is a lot of like reports coming from the user. Is it like normal, or is it like suddenly have a lot of like errors reported? Again, very quick. I think I'll just recap this along with other fields that we already talked about, like these 2 days. I'm afraid I'm a bit over time. Yeah, so this one, I think you can just screenshot this and see it at home. But basically, you will see that there are different skills, yeah, among these different fields that are overlapping, and you will need this. You will need to develop this, and it will open up many doors to different careers as well. Okay. Just basic suggestions for every one of you. Make sure you don't limit yourself, be resourceful, and see and try, like different, maybe look at your different processes in your daily life and see what's interesting for you. Is it the design process? Is it the communication process? Is it the make sure everything is optimized process? Those kind of things are very important for you to look at. So I think that's pretty much all for today. Maybe let's just give you, get to our feedback form over here. I think you've looked at this previously. So yeah, please kindly give us some feedback about today's session. I hope it's not too fast. I hope it's pretty new for all of you, but also not that, it's challenging enough, but it's not, high above the clouds, difficult, and I'm pretty sure it's quite simple for everyone. Just click on the link that Ms. Tricia already put on the chat box, or scan this using your cell phone. I'm really looking forward to seeing all of the responses over here. And maybe later I can also take a look at the duplicate spreadsheets, see that if everyone get the same results. And yeah, feel free to download it and keep it, maybe play with it later on, create your own control charts.
All right.
Okay.
Thank you, Miss Sharon. It was very applicable workshop. Yep.
Thank you so much. Hope
Actually, I
helps.
missed it. I didn't finish it.
Okay, still have time to do it later on.
Okay. All right. Thank you very much, Miss. And I hope we hope that we will see you again. And students, you can go for 6 minutes break. Yeah. When during the break, you can do the feedback form, and then we'll come back again at 9 o'clock with another session. Yep. All right. Thank you, Miss, again.
Thank you so much,
yeah.
Mr. Julius, and everyone, and all the teachers over here. Thank you so much for joining this session. Yeah, thank you.
Mr. Tyler.
So Miss Maria, shall we start? Yeah.
Yeah, Mr. Yulis. So good morning, everybody. I would like to actually, Pak Yulis is going to introduce the two sessions now. Yeah.
Yeah, okay. So today we will have two universities will present. The first one is University of Canterbury, and the other one is Oregon State University. Yeah, so now you may go to each breakout rooms that you prefer, and we will wait you there. Okay, I'll see you in the breakout rooms.
All right. Can everybody join? Pak Yulis?